This is a workforce scheduling example. So these are the number of people, employees needed on these days, and we need an employee who works 5 consecutive days, and we want to see how many will be starting. So we want to minimize the total number of workforce here, and these are the constraints. So the number of people can be more than what we require for that day. So we are going to use risk solver platform to solve this optimization model. So the cell C22 besides total is going to be our sum of the scheduled decision variables, which are these, as you can see here. So these are the decision variables. We will select those as decisions. So it comes on here. Next, we will select our objective as the cell C22. Click on that and you say minimize since we want to reduce the number of employees, and we click on OK. After that, we want our constraints. So as you can see, the number of working people can be more than the number of needed employees. So we give the constraint here for normal constraint, which is more than equal to. We select this range, which is greater than the number needed range. You say OK. Our next constraint will be that the decision variables are an integer number because it's a number of employees, so it cannot be anything else. So we just go in variable type bound and click on integer after selecting this schedule decision variables. So as you can see here, all our data has been stored here. Our integers over here as well in the constraints. We have this formula here for Saturday because we want to see for 8 different scenarios for different number of employees required. So we have a formula here which is psi optimum parameter, which is M10, which is M10 to M17, and we have a formula here for total needed, which is psi optimum value. So it's from C22, which is going to be the optimal, and for the number of scenarios. So that's the formula. So for now, it's just going to generate for the first scenario, since we are just going to be using the answers for the first scenario right now. So we will just go on engine and click on a standard LP quadratic engine. We will then go on assume non-negative, so we will say it as for true, and that's it. So we will run this model. So as you can see, the total number of people required is 3, and for Saturday, as you can see, it's 20. So now suppose if you want for more scenarios, so what you can do is you can go in platform and optimizations to run. You write 8 and you press play. So for different scenarios, you get the number of people required, and this is your graph.